in this video, we're going to talk about implicit differentiation. Implicit differentiation is not new formula, not new rule. Okay, it's just when you're given an equation, how do you find the derivative of y with respect to x, meaning the rate of change of y as x changes. Okay, so this is the equation. Okay, so when you're given an equation, f of xy equals 0, this, I can give you an example. For example, x squared times y squared plus 3 equals 0. This is the equation. And what you have been dealing with is y equals f of x. So this is a function. You have very clear input and you have very clear output. So for example, you have f of x equals x squared times sine of x, let's say plus 1. So this is like what you have seen, like a function, and this is what you have seen as an equation. So you have a bunch of derivative rules as well as formulas that helps you how to find f prime, right? And if I say, oh, the output value, that's called y, then I can also write this as dy dx, right? And we're gonna learn, in this case, when I don't have very clear y equals something only involves x, how do we find the dy dx? Okay, so this is what implicit differentiation is about. And implicit differentiation is easier than you might think. It just, you take the equation, differentiate both sides of the equation. Okay, so what does that mean? I take this equation and I take this equation. Let me write down the left hand side. Differentiate. So I apply the verb differentiate to the left hand side. And I do the same to the right hand side. And because they come from the equation, so I know after taking derivatives, the left hand side still equal the right hand side. All right, so very quickly I know that the derivative of a constant is equal to 0. Doesn't matter if it's 0 or 1 or whatever, as long as it's a constant, derivative is equal to 0. All right, so now I need to focus on this part. ddx x squared times y squared plus ddx of 3. That is a ugly 3. Let me fix it. 3. And it's, again, what do we get from the left hand side equals what do we get from the right hand side. All right, so once again, here I have the derivative of a constant, so this goes away, becomes 0. All right, now here's a key. You see two variables, x and y. In your mind, only in your mind, you don't write it out. In your mind, you're gonna say y is a function of x. just like here, f of x, or you write y of x. You're gonna see this as function of x. Okay. So we don't need this part. So let me erase it. Right. And let me focus on the dx x squared y squared. Okay. Right now I only look at this part, and I will come back to the equation later. So we're thinking y is a function of x. Now here we have a square function times a y function, okay? Y squared. Therefore, to differentiate this guy, I need to apply the product rule. So it'll be derivative of the x squared times y squared plus x squared times the derivative of y squared. Okay, but whenever I write y, I always think y is a function of x. Okay, y is a function of x. For example, you could have y being sine of x if you want to. Okay, all right, so let's continue. Derivative of x squared is equal to 2x now times y squared plus x squared. Now we need to focus on this part. So you see y itself represents a function of x, and on top of that you take the square of y, so it is a composite function. Think about this. If y was a sine function, was a sine of x, then y squared would be sine x squared. Now you want to differentiate this function. So it is a composite function. Okay? Now you're differentiating a composite function. The square function is the outer function. The y function, y of x, is the inner function. Therefore, I need to apply the chain rule. Derivative of the outer function is 2y, right? Derivative square function is 2 times whatever you have, times derivative of the inner function. I don't know what the y is exactly, but I know I'm supposed to see y as a function of x. So if I differentiate y with respect to x, this is our notation, right? When I have y equals f of x and I want to differentiate this function with respect to x, I write my result as dy dx, right? So I don't know what a y is, but I know that the result of the derivative would be denoted by dy dx. Okay? So this is the key concept. This part is the key concept of implicit differentiation. Implicitly, you treat y as a function of x. You don't write it out. So here whatever I write in red, you should not write it out. You just think that in your mind. So you treat y as a function of x, but you don't write it out. You treat y as a function of x, you don't write it out. You treat y as a function of x, you don't write it out. So this part is the crucial part. You treat y as a function of x. Therefore, when you differentiate y squared with respect to x, you know you're dealing with a composite function. The inner function is the y, because y is y of x. The outer function is the square function. So when you apply chain rule, derivative of the outer function times derivative of the inner function. So this part is very crucial. Okay, you need to know when you're dealing with a how do you put that, composite function. Okay, so we now have derivative of x squared times y squared, we now put this into the equation we have and see what we get. So everything together, we have 2xy squared plus x squared times 2y times dy dx plus 0 equals 0. So this whole thing equals 0. Okay. Now what I want to do is to keep dy dx on one side and throw everything else to the other side. Okay, so let me do this step by step. I first move this to the other side. So I have x squared times 2y dy dx equals minus 2x over y times y squared. Okay. Now I divide the equation by 2x squared y. So I have dy dx equals minus 2xy squared over 2x squared y. All right, and now you can simplify your answer. So 2 cancels. You can cross. So both the top and the bottom have a copy of x times y. So we can cross out the xy. So I have a single y with a minus sign coming from here left, and I have a single x left from the bottom. So this is the derivative dy dx using implicit differentiation. So when I say using the implicit differentiation, you're not really using any tool or new formula. All you do is keep telling yourself you should treat y as y of x without writing it out.